through some categorical topics which are right now the very famous or very trending topics for research. And if you are wanting to, move your trajectory of career towards research and development, then this would be a good informative session for you. Also, right now, initially we'll start with the history of space exploration. As you can see, that is the first point. While talking about history, I'll take you through some very first achievements of human mankind, because that would be necessary to know how that things came into picture and how long back they came into picture. Then from history of space exploration, we'll move to evolution to see what we have achieved, how far we have come right now, and in which direction are we moving. Third is the innovative advances. There are some particular two technologies named here, which I'll be talking about, which is the right now research topic. Then it would be benefits of space missions. It is need not to say that we are hugely benefited by space missions and space exploration, and you all must agree to me, because even the smallest things in our life routine cycle we use is somewhere related to particularly space exploration. The mobile phone, the GPS that you use in your mobile phones is particularly connected to the satellite. Okay, so that is one of the uh, benefit of space mission. And the last would be a major segment, that is careers in space industry, because that is the final segment which will enable you to make sure what decisions to take, how to pursue your career in terms of higher education or even now. Right. So if I talk about 1930s and 1940s, Nazi Germany saw the possibility of using long-range missiles as weapon. And in Second World War, Nazi Germany attacked London with a 200-mile range V2 rocket. This is the V2 rocket that Nazi Germany used. Now looking at this particular technology, but not to its destructive tendency, Russia and America thought to use it for some constructive work for the mankind. And that is why in 1957, the first artificial human-made satellite to be launched into space was Sputnik 1 by Russia, Soviet Union at that time. From the launch of Sputnik 1, 4 years later, in 1961, we marked the first human beings, presence into space. That is Yuri Gagarin, which was a Russian lieutenant commander. And the third one is Explorer satellite that was launched 1 year after the launch of Sputnik 1 by America. And that was the first achievement for America in terms of the launch of satellite into space. The first telescope is said to be, it is believed, but we do not have any proof. So it is said to be made by Hans Lippershey. He was an eyeglass maker in Netherlands. And there is a space telescope. Now, if you may not be knowing, I'll brief you about it in later sections. Why is it that we always choose to have a space telescope rather than having an advanced telescope on ground? Okay, there is certain advantages and disadvantages to it. But right now we'll see that Observatory 2 that was launched in 1968 was the first space telescope. First space station was again by Russia, because at that time the space race was even started and initiated by Russia. The first few achievements were by Russia. So Salyut 1 is the name of the first space station that has ever flown into space, and it was launched in 1971. While if you may be knowing that the International Space Station is a combination of parts made by several countries. So the part which Russia made was the final module of the program Vesda. Now, one interesting thing, or maybe I should say one tragic thing about Salyut 1 space station was Soyuz 10 was a capsule in which astronauts were supposed to dock into the space station and then live there, conduct some experiments, do some research, and then come back to Earth. But the hard docking of Soyuz 10 to the Salyut 1 space station did not happen. And that is why they had to abort the mission. They never went into the space station and they came back to Earth. While Soyuz 11 had a successful hard docking, the astronauts lived there for I think 23 days. They conducted their research and experiments. But while undocking to come to Earth, there was a failure of valve which caused asphyxia, and that is why all the astronauts sitting into the Soyuz 11 capsule died into the space itself. So their dead bodies arrived in the capsule on Earth. So that is one of the very rarest of the rare tragic movements or accidents that have happened in space technology or space exploration. But right now we all know that how safe and how sure the organizations be when they are planning some manned missions. As I mentioned earlier, the first human space flight, everyone knows this. It was by Yuri Gagarin. He was a Russian cosmonaut. It was in 1961, and the flight lasted 108 minutes. It was in low Earth orbit. One important thing to know that his landing on Earth was not as usual as it is right now in today's time. He ejected himself, he parachuted himself at the 7 kilometer altitude from Earth. So that is how the capsule fell off on the Earth while he parachuted himself. This is a very animated and a cartoonic image of his capsule. Now we'll see evolution of space exploration. There are some international endeavors which I think it would be right to say that people who are not even by far connected to space science or space technology may be knowing about these achievements. The Hubble Space Telescope, Apollo 11, International Space Station. While India has not been, it has been competitive. It is not lagging behind some any other nation. So the achievements are Aryabhat, the very first satellite, communication satellite, Chandrayaan 1 Mars orbiter mission, Chandrayaan 2, which I must say is said to be a very successful failure because we learned a lot of things from that thing. And Gaganyaan is an upcoming project by ISRO planning for manned mission. Hubble telescope is a space telescope. Remember, I told you that I would brief you about that. So, space telescope is a telescope placed above the rain clouds, above the dust and pollution and water vapor of Earth. Because simplest I could explain to you is that even let's just eliminate dust and pollution, even water vapor chews up pristine microwave signals coming from space. That is why we need a telescope above from the atmosphere. That is why Hubble Space Telescope. And it started its operation in 1990. And there were 5 servicing missions because there were some problems regarding the adjustment of a lens into the telescope. So that is why 5 missions were flown to the Hubble Space Telescope to make some adjustments. While it's more than 30 years of operations right now, has made it a very productive scientific instrument to be ever made on planet, because the data which is being taken from Hubble Space Telescope and is being used in making research papers, by that data till date 15,000 scientific papers have been made with the help of Hubble Space Telescope. So that is why I must say, and also 1.3 million observations have been taken, and this is just an approximate value, right? So that is how it is so much important and productive. We'll see some of the discoveries by Hubble Space Telescope. The first one is the Eagle Nebula. It was discovered in 1995 by observation using Hubble telescope, and it is called the Pillars of Creation right now. Second is the first visual image of an exoplanet, that is Fomalhaut B. And sorry, third is the water vapor, true colors of water vapor erupting from the surface of Europa, a moon of Jupiter. And there are several other discoveries as well, but these are some notable ones. While Apollo 11, we all know that the president of America in 1961 said that landing a man on moon and bringing him back alive on Earth within a decade is a mission right now, and which was fulfilled in 1969 by NASA, and Neil Armstrong was the first human being to, take that one giant leap for mankind. While International Space Station, as I said, is a collaborative effort, and that is a symbol of, making a statement that competitors are not required in the space field, in the space sector. It is a collaborative thing. While Indian endeavors, as I mentioned, Aryabhat, the first communication satellite, it was transported on a bullock cart because we were not very efficient in that terms at that time. While Cartosat 2B and India's world record of 104 satellites, right? You must be knowing this thing. It was, I think it would be right to say that this was the one of those achievements which made the mark of India, which made the mark of ISRO in the world map in terms of achievements in space technology or space exploration. Chandrayaan 1, a very successful mission, Mars orbiter mission to India to be the first nation to have achieved it in the first attempt, while Chandrayaan 2, a very successful failure for India. Now, James Webb Space Telescope is an innovative technology that is being developed right now. That is similar to Hubble Space Telescope in terms of it is a space telescope, not in other aspects, because Hubble Space Telescope uses visible light spectrum, while James Webb Telescope will use infrared spectrum of light. So that is a big difference. While Hubble Space Telescope is in the orbit of Earth, while James Webb will be placed at a Lagrange point, L2 point, at which the combined gravitational effect of Earth and Sun cancels out each other. So that is why even at that point, which is far away from Earth, the orbit period of the James Webb Telescope will be same as the orbit period of Hubble Space Telescope. And its major objective is to find the farthest object, farthest celestial body, so that we can see how back into time we can go, because light takes time to travel. That is why the far we see, the more back in time we see. This is a smart suit technology. For if I want to make it short, I'll say that instead of using a passive pressurized gas bag, which is being used right now, we are using a soft robot technology and a soft stretchable material that is self-healing, and it also is embedded with sensors so that astronauts are being able to see their body parameters changing. Now, why the need to explore is because we are benefited with it a lot. Some of the notable achievements and in terms of how easy the life of a human being has been made is because of implantable heart monitors or maybe improved computing systems. If you are from mechanical or aerospace, you may be knowing computational fluid dynamics, right? And other than that, the partnerships, trust, and diplomacy that can be built between nations by a very good example called International Space Station. Now we'll see careers in space industry. I think it is by far enough for you guys to understand why you should choose a career in space sector and in what aspect you can contribute, because you have seen whatever contributions and whatever achievements have been made till now is into some separate aspects of the space sector. Let's say if it is a suit technology or maybe a telescope technology, let's call a manned mission, everything is separate, right? So maybe you can choose now better, with the information of how your department right now, how your field can be connected to it. So this is a topical guideline of how I'll follow into later sections. The left corner says introduction, and it is followed by 4 questions. I'll answer those, and I'm sure that with those answers you will have some other questions in mind which will be answered in the other 2 sections. Okay, so why space study? Now, if you are, a problem solver kind of a person and you are creative in terms of analysis and thinking of using particular resources in a particular way to make the process efficient and to make it very, effective, then you are made for this sector, because everything here is about creativity and problem solving. And mind you, there is a very misconception that the people into the space sector are only called space scientists, or only the space scientists apply or maybe are in the space sector. That is not a true thing. People are drawn from the ranks of engineers, mathematicians, information technologists, and whatnot. Okay, as I mentioned, various people from various backgrounds are taken. Now, this is some very conceptual elementary topics which are needed as your foundation. So these things, if these are not particularly to say that you need to be good in all of these, but whatever your respective field is, whatever your department is, you need to be sound into those concepts. So some of them are mentioned here. Okay, so this is an educational guideline for people to follow beyond high school. So normally, at least a bachelor's degree is required. Maybe you, if you want to go into science, then it would be a BSc, and if in technology, it would be BTech or BE. So that would take respectively 3 and 4 years. So that is a minimum requirement. Now apart from that, a master's degree can be beneficial to you in terms of how deep you want to go into that particular concept or knowledge of that particular sector. That is why a master's degree take 2 years for specialization, while an additional 4 to 4.5 years is taken to complete a doctorate program. Here it is mentioned 2 to 4 years, but mind you, it is said 2 to 4 years, but it usually takes 4 to 4.5 or 5 years. Now let us address the problem, that is people confuse space science and space technology. So space science is particularly pure science. You cannot discover anything in science. Sorry, you cannot invent anything in science. You just discover things in science, like physical laws or physical phenomena. You observe, it is already present in the nature. It is already happening. It is already occurring. You just discover it. You find it out. That is called pure science. That is called knowledge. While using that knowledge to invent something, to create something, to develop something, to ease up human life, such as the technology of vehicles or the technology of using smartphones or maybe electronics, or the technology of even having the technology of light, electricity. So that is what space technology stands for. It is the application of that particular science, that particular knowledge. So space science is completely about discovering things. It is pure science, while space technology is the engineering domain. Now we'll talk about space science first, and then we'll see the engineering part, space technology. So first of all, we divide space science into three major categories, that is physics, chemistry, and biology, because mathematics is a complete separate part, which you if you want to apply as mathematician, then it is a separate thing for space sector. So first of all, we'll look into physics. Now we all know physics is the most fundamental thing in our life, in our world. It contains every information about the universe, from the biggest and largest objects to the observable universe to the smallest particle ever present in the universe. Right? That is what physics stands for. And we have made notable achievements and contributions to that achievements in physics. Maybe let's say right now, if you talk in terms of medical services, then too some things are possible which were not before. So that is how it has benefited us, and that has three particular categories. The first one is astronomy. Now while talking about astronomy, the first thing I feel is, who hasn't felt an awe while looking into the space, into sky, right? So that is how creative and that state of spiritualism, I think would be right to say, that you get into when you look up into sky and you just feel at ease. While the scientific part of astronomy is that whatever you see, whatever you can see in the universe, whatever you observe, that is astronomy. From planets to asteroids to meteors to comets to distant galaxies to distant clusters, Virgo supercluster, anything. anything that is observed into space in universe, that is astronomy. While second is plasma physics. Now plasma physics is a rich physics phenomena, complex also, but you would be amazed to know that we are surrounded by ordinary matter, right? Like the state of matter are solid, liquid and gas. But the amazing thing is plasma, being not very famous in terms of people knowing about it, it is one of the state of matter which is abundantly available in the universe, but it is not available in free state on earth. That is why we are not really aware of plasma as a state of matter. Otherwise it is the most abundant matter available, abundant state of matter available in the universe. While also plasma physics will be important to establish and to make sustainable fusion reactors for space technology. That is why the advancements in space science is as important as the advancement in space technology. Well, third one is particle physics, which tells us what we are made of, what the world is made of, what makes the world held together. Everything that the fundamental thing, the smallest you can go is particle physics. While you should also know that the MRI and PET scans that a doctor uses to see inside your body uses particle physics, right? Now, this is something about time travel, just a fascinating concept to ignite some creativity and some curiousness into you. So, right now, I'll just explain you what is the situation that if you are traveling with the velocity of the speed of light, then the time is not moving for you. Okay, but that technology is not available with us. We can't create that much energy or even velocity with respect to that energy, that we can even achieve anything near to space to the speed of light. That is why it is not possible for us, but it would be someday, fortunately. And for your understanding, time travel would not happen into future or past. It is just that the person who is traveling at the speed of light is not moving in terms in the trajectory of time. The time has been stopped for the person who has been traveling at the speed of light. It is not that he is going back into past or he is going into future. He is just stable there, while all the other things on our planet and other things in the universe age. Now, third one is chemistry. Astrochemists, the main roles or responsibilities, if I have to say, is to interpret and give explanation of the data that has been observed into the universe. So they use certain quantum chemical equations for that interpretation. And biology has three particular categories. The first one is astrobiology. So according to the definition of NASA, the study of nature, evolution, distribution and future of life in universe is astrobiology. In short, the study of living organisms, be it human or non-human, is the study of astrobiology. That is important to know extraterrestrial life, whether any organisms or any bacteria or anything, any living organism is present in any other planet or any other celestial body or not. While second is astrobotany, and astrobotany is important for a regenerative life support system for a particular space flight or manned mission. Because if you want to travel deep into space, interstellar travel, then you cannot take your food and water with you. You need a regenerative life system that will make you enable to create your own food and water into the space shuttle, or let's say any space station if you want to say. The third one is bioastronautics. Now, bioastronautics is to make a habitable environment for the astronauts, because they are in space, they are subjected to weightlessness, space radiations and psychological discomfort. Even some have vision problems. So that is why the technology and the inner environment of the space module should be such that they are feeling comfortable and their body supports the environment. This is about a non-profit organization that is called Search for Extraterrestrial Intelligence, SETI, and it aims to explore the origin of life in the universe. So it is just another thing like a time travel to, to spark some curiousness into you. So it tries to make contact and to, detect some information or any signal that they can have which may prove that there is some extraterrestrial intelligent life. Well, some other interesting fields are mentioned here, which are not particularly a career objective, but then too they are used some way or the other into space sector. And apart from the technical stuff, if you just love the universe and the cosmos, then these are also a particular career line to follow. You must have seen Interstellar and movies like those. Now we'll talk about space technology. I think you would be interested to know the last segment because it is more concerned to you guys. Okay, so there are a lot of things that you can work upon being in space sector as an engineer. Maybe let's say satellites or probes, rockets, spaceships, maybe suit technology or telescopes, space telescopes, anything. So there are many other different aspects of space sector which needs engineers, efficient engineers like space stations or even ground equipments, communication technology from ground to space. Everything is being done by engineers. Now, to become an engineer in space sector will require the educational requirement of at least BTech or BE, then followed by a master's degree if you want to pursue. Other than that, if you want, then you can follow the master's degree with a doctorate degree. The programs of study are aerospace, chemical, computer. As I mentioned, any department you go will have some or the other notable contribution to the respective field. Now, these are the skills you will require as well as you will grow with time if you go into space sector. First is analytical skill is means to analyze the situation, to see what resources you have, to see what problem you need to solve and how effectively you can use that resource to solve that particular problem. See, I'll give you some particular examples, right? What is the job of engineer? That is very important for you to have in mind because the right now present situation says that engineers have no scopes and stuff like that, very depressing and negative environment. But you must know what is your job as an engineer. What are you supposed to do? Not some particular roles that if you are a design engineer then you need to design some impeller. That is not a job of engineer. That is just the role and responsibility that a company offers. The job of engineer is to solve problems. For example, particularly in space sector, there is a problem that the rover on Mars cannot be operated from Earth because of 15-minute communication delay. So what will we do? So the solution is put up an artificial intelligence system into the rover so that it could work autonomously. That is the solution, and that solution has to be brought by an engineer. Then another problem, let's say, was how to use less fuel and to cover more trajectory, more path in a space flight. And that is the problem. And the solution was, let us use the gravitational force field of a planet, and we can get a slingshot from it. So that is the solution brought by an engineer, right? So these things are needed to be very clear in your mind. The second is some business skills because there are some federation laws which needs to be fulfilled while you are designing something. So that is why while also startups and other making some contribution in ISRO or maybe your own startup comes into business skills. Then critical thinking skills, math skills is the most important one, problem solving thing, and writing skills. The last one is important in terms of when you research something, when you do something innovative or great, maybe you have taken some initiative and you have achieved something, it is important to add that knowledge, that information into the body of knowledge of the world. That is why you need to write the research paper or review paper, whatever contribution you have made, so that the world can use that information, that knowledge to pursue further advancement in that particular technology. That is why writing skills. Now, this is the last part of the careers section about what are the particular jobs of such particular departments and people from those departments in space sector. So if you are from aerospace, it is like a generalized field, a generalized department which specializes in many things like structural design, telemetry, communication, orbital parameter, space dynamics, and everything is being taught in aerospace. While computer and software, you must be knowing that the computer systems that are embedded into the space missions, into the space shuttles or the space station, are being developed by computer engineer, while the softwares whichever are going to be used into the space mission are created by software engineers, while electrical and electronics engineers are used to manufacture, install, maintain, and repair the electrical sets, whatever is being used in the space mission. While it must be, very clear for electrical and electronics engineer to be very efficient in their jobs, because the only way a a station, or say a space module or capsule, can catch fire is because of a failure of electrical equipment. Other than that, there are very less possibility or very less chances for a space station to catch fire. That is why they need to be foolproof. Okay, next one is materials engineering. And I shall say, if there are right now in the world, in technology sector, in engineering sector, if there are 1000 research topics available, then out of 1700 research topics are going into the material section, because it is the most important thing today to make efficient materials, to make lightweight materials like composite we use in making our aircraft and jet fighter planes also right now. Even in terms of how your electronics works, first of all, the computers were huge. Then there are some changes in materials, some inventions in materials. So the lightest laptop, lightest mobile phone, everything is dependent upon the advancement of materials. That is why it's important. While avionics and instrumentation combines of having the parameters check in the space station, or say even airplane also, aircraft, it requires avionics, because the cockpit consists of all the instruments which are required to see the performance of the aircraft, how it is doing, while also to see the trajectory and to have a proper location of their particular vehicle. Robotics is the third one, and it is important because it is dangerous for astronauts to go out into space and do some repairs or any work. That is why we always tend to use robotic technology, so that the astronauts are protected into the space station inside the capsule, while the robotic techno, whatever the robotic arm, or maybe say a complete robot that can particularly do that thing, that task. While the last one is telecommunications, and telecommunications is very important actually, because if you lose telecommunication, then you lose the complete mission, right? If you can't receive back the information, if you can't send feedback, then the mission is a complete failure. That is why it's important. And also you must be knowing that whenever in case of Mars orbiter mission also, when the orbiter was going behind the red planet, so that is when there was a blackout of some minutes, and that is where the telecommunication engineers were called in to see how fast we can come out from the blackout. So that is, there are some roles and responsibilities of particular fields. So I hope you must be right now clear with what department offers what things in terms of contribution to the space sector, and what you can right now contribute in what way, in what sector, and how you can pursue your career into higher education, say, or into the corporate world also. So that's it from my side. I hope it was an informative session. I also thank Nakshatra Club, Ankita especially, because she is the one who's took that initiative to arrange this webinar. So that's it from my side. I'll be open for Q&A session. I'll entertain every question with what knowledge I have, and I'll try to put my best for it. So that's it. Thank you.
Anyone having any doubts, please kindly switch on your mics and ask them.
No, it's okay if they write in the chat box also, because that way they would be more comfortable. There is a question from Tejas Patil asking, "Sir, how could we enter in an astronomy field for jobs?" See, astronomy is not really a technical sector in terms, because it is, but you can't really choose a career into it in terms of doing a course like a BTech degree and such thing. So that so you need to enter astronomy. You should first decide what particular thing you want to do in astronomy, right? The first thing is being in an observatory. There are huge observatories around the globe, okay, by which you must be knowing that the image of black hole was also computed and was recorded by such observatories only. So you must first decide what are the complete roles and responsibilities of people who work in astronomy field, and then you must see what is your particular interest or what is your particular thing that you want to contribute, and then see how they are planted and where they are planted. If there is a certain job of using a telescope or operating a telescope, then they are planted into the observatories. Then you need to know that this thing is what you are interested in, and that is how you should go into it. Aditya is asking, being a mechanical engineer, sir, how can we mechanical engineers contribute to the field? See, mechanical engineering has three particular aspects. Okay, if you must be aware of this thing. The complete mechanical engineering is divided into three parts. First one is design, the second one is manufacturing, and the third one is thermal and fluid. So design comes under, in space sector, comes under some particular nozzles or whatever system design are required for that particular space mission. So that is where you can come in as a design engineer. That is the first job opportunity. Second is the manufacturing engineer. That is the biggest and largest requirement of all industries, because if you are doing some specialization in manufacturing, being in mechanical engineering, then you are required in every damn place. Because be it space sector or any sector, you need some instruments or some vehicles, maybe say rockets or space stations. Everything has to be manufactured, right? And that is being effectively done by mechanical engineers. That is their jobs. And the third thing is thermal and fluid. But mechanical engineers who are who have just completed that bachelor's degree do not get recruited into thermal and fluid, because that is a field, a department, or a specialization which requires in-depth knowledge, and that is how you will get if you pursue your higher education. So that thing is required for thermal and fluid, while notable contributions can be made by being a design engineer or a manufacturing engineer.
So next question is, so what if we don't know any detailed knowledge about astronomy but still want to learn about it? How can we proceed?
See, I'll suggest you to read some good books. That is the least thing you can do to start from very basics. There are many great astrophysicists and astronomers also who have written some good books, some technical, in-depth, knowledgeable books. So you read that, you do simple Google search, you will come up. It will come up with many names and books. You see which you read those indexes and you see what topics matches to your interest, what suits you, and then start reading those books. That is the first thing, because when you read those books, as was the aim of this webinar also, first you were shown what things have been achieved, in what way, and what all things are going right now. So you will see that particular thing in particular books also. So that is when you will see how you get connected to any particular technology or any particular field, right? So start by reading books.
So could you recommend some resources or some authors which could be helpful for amateurs such as ourselves?
Sorry, what was the last section that you said?
Could you recommend or suggest some resources like authors or reference books for amateurs like ourselves, for to
Okay,
someone
so
who needs to know more about this field?
okay, so there is an author called Neil deGrasse Tyson. You must be knowing.
Yes,
His
sir.
many books are very basics in terms of in terms of understanding. Okay, so it would be very easy for you to understand, because I have read his 4 to 5 books when I was in 12th standard and in my first and second years of BTech. So I'll name some books if you want. The first one is Death by Black Holes. The second one is Astrophysics for People in a Hurry. I think I remember those two only right now. Yeah, yeah,
Okay,
that's
sir.
it. Okay, so you go by these books, you will understand what things are being observed as astronomers, what things are being used as astrophysicists by that details that is being provided by astronomy. See, I'll mark some very difference between astrophysics and astronomy. Albert Einstein predicted that the space-time is a continuous continuum. Okay, it is intertwined in itself, so it is not separate. So the one effect of that thing was gravitational lensing. That when a light ray comes from a far object, it would bend and it would have a trajectory different from a straight line if it passes through if it passes very near from a large celestial object. This was his prediction due to mathematical equations and some theoretical concepts. Now this thing was observed by astronomers. That is the job of astronomers. They proofread whatever the astrophysicists predict. Also, they have their own particular research as well. The astronomers, the inventions, not inventions, but the discoveries of the exoplanets. And the if you may be knowing, there is an asteroid search campaign going for amateurs. So that thing is also coming under astronomy. So I suggest you that also by saying, and I just remember that you must apply yourself as a team or as an individual into the asteroid search campaign. You write those keywords into Google, and you will see some organizations that is solely made for amateurs. Okay, so that is how you will have a glance of using some telescope from your laptop. There are also some other websites that if that needs but some paid subscriptions that allow you some time slot in which you can use some telescope of a particular observatory from your laptop. So whatever way you want to move the telescope, it will happen at that particular place from your laptop. So that is some advanced level, but I think you should start with being a part of asteroid search campaign. I hope that
So,
satisfies. Yeah.
so then next question in the chat box is there a way we can use artificial intelligence to solve hard questions relating to the universe?
That you need to define what you mean by saying hard questions. Shrusti, you need to do that for me because I want to really know what kind of questions are you referring to. If you want to, if for example, if you want to refer to extraterrestrial life, extraterrestrial intelligent life as a hard question, then I don't see how AI can solve it. So I'm sorry, but I can't, answer that particular. If you can elaborate your question a bit, then I can try to answer it.
So the next two questions are on a similar note. So here they are. So what are the business opportunities in aerospace technology, and so how sustainable can a newly established private space company in India can be?
Okay, so see, regarding startups, there is the privatization has been started, but it is not up to the mark in India. I think you must be knowing there are some, if I'm not wrong, only two collaborations with ISRO, the collaborations of two private companies. One is quite famous, is called Skyroot, and that has been collaborated with ISRO, if I'm not wrong, maybe 2 or 3 months back. So the collaboration somehow says that the ISRO satellite would be launched into orbit using Skyroot's launch vehicle. Still, you confirm the details, but this is the thing for sure. While sustainability is when it comes into picture, it's quite a question in India because then you need to be very efficient in your planning, right? You may not be knowing about these things, but there are quite a few companies which are very, private limited space companies right now in India. I know a group of students from third year who have made some similar company. There is also a similar company from Surat, Gujarat. But those companies you don't know, and people also don't know because they are not so much in light, and they are not so much in light because the planning and the actions are not effective. They must be effective, but not in terms of being in India. If you want to start a company in India, you must select your a topical guideline of your project, how you will approach the problems, how you will approach the collaboration. Because without collaboration it's difficult to start that particular company. You can't make the launch vehicle and the satellite and launch it with your you know a personal launch pad, or maybe using Sriharikota. That is where you need to see what collaboration opportunities are possible, and that is when you need to research the website of ISRO, what collaborative opportunities they are providing. Because if you know SpaceX, then you must be knowing that how many people work in there, right? So because making a satellite and launching it requires huge number of people, everything has to be checked twice and thrice and 10 times, because one moving part goes wrong and the complete mission is a failure. So that is why you need to be very effective in practical terms. The way India is carrying forward its space technology, the way ISRO is carrying forward it, the way they are opening up to opportunities for private companies, that needs to be studied first. Then you should launch your startup. Because if you find that there are not enough opportunities, then your startup is going to fail in one way or the another. Because you can't have 500 people in your company on the first day, or even after a year. Or even if you have, how will you satisfy them in terms of their salary? So that is, there are some particular problems into such privatization in India right now. But by looking at the collaborations of Skyroot, and there is another company as well, I don't remember the name. So there is hope that such collaborations continue in future also, because that all depends upon the success of Skyroot and that other company. Because how successful privatization has been, then ISRO will also maybe think about passing on some some particular missions, or establishing or making some launch vehicles to some private companies. That is where privatization will grow continuously and more rapidly. So the only advice, first study, do your particular research in what opportunities are present there and what not. Apart from that, you must be knowing what resources you will have if they are providing the opportunities. Consider those two things, and then go ahead with the startup. Yes.
So the next question is on a bit of a personal note. So what were your successful failures that helped you become successful in life?
Okay. I think there are, to be honest, there are not many. I'll Because there would be many, but I don't see life in that way. So maybe I am not looking at it that way. But some one, two, I think one or two I'll mention that while in 11th standard, in the second term of examination, I had a very low score in physics. I scored some 39 or 40 out of 100, while in 10th standard my percentile rank was 99.95. So I was that bright a student in 10th, and in 11th, maybe because of going to tuitions and stuff like that. So for some particular reason, I my grades dropped, and my parents were very ashamed of that thing. But because of that particular setback, I felt that it is not who I am, and it is not how this thing is supposed to be. So from that day, the result came out. From that day, I lifted myself in terms of studying for subjects and grades. Also, with having that in mind, you must study to understand things, because ultimately your grades are just a ticket to enter an interview. Because right now you go in any organization, you go in any company, your selection is solely based on interview. The grades are just a window, that above 7.5 SPI or CGPA we take participants, and below 7.5 we don't allow them. So your grades are just a window to enter some interview. Apart from that, you score 10 SPI or 9 SPI and you are not sound in your concepts, then those SPI are not of any good. Okay, so that first thing. And second thing is, I have done mechanical engineering in my BTech, because I am from Gujarat, and here in North India, you must be knowing, maybe in Maharashtra also, that may be the scene, that aerospace or even space technology, space science is not so much lifted in terms of awareness. There are not so many colleges offering aerospace technology or aerospace engineering course as their BTech or MTech program. So that is why it was quite difficult after completing 12th to move forward to South India to pursue some aerospace education. So that is why I pursued mechanical first, and then I had aerospace propulsion technology in MTech in Bangalore. So that is how I don't see it as a setback, because major things of mechanical engineering is being used in aerospace. I'll give you an example that in mechanical engineering you study fluid mechanics. The fluid consists of gas and liquid both, while in aerospace engineering we use only gas, because there is no liquid involved in terms of space flight or atmospheric flight. So that is how that thing gets a particular screening while transitioning from mechanical to aerospace. So your knowledge is not wasted, but I still hope that I would have pursued aerospace engineering in my BTech. So yeah, those things. That's it.
So one of the questions next is what questions like what was before the Big Bang, or like how
Right.
to find out those, or how to prove the theoretical equations, and how long it might usually take.
See, before we every effort in space exploration is for two things. This you must know if you are interested in space science or space technology, or you want to go and contribute anything in any aspect. Why space exploration is needed is not because that is a one aspect, that you want to travel into space and you want to make some space colony, or to shift from uh, earth to some other planet, or to be an interplanetic, if I'm not putting it wrongly, a species. So that is just one aspect. The major two aspects, I should say just one, is to have a unified equation, a unified equation of all the forces of all the physical phenomena, right? An equation that defines everything in this world. So I'll give you an example, that force, the second law of Newton unifies force and acceleration, right? F equal to ma, the rate of change of momentum. So when you have that unification of force and momentum, sorry, force and acceleration, then you know that the change in momentum will create thrust, will create force. And that is the same physical law that we use in our vehicles, let's say two wheelers or four wheelers, or maybe even rocket technology. We use that principle, that momentum principle. The rate of change in momentum will create force. So this idea came with the idea of establishment of unification of these two quantities. So that is why we need to quantify or unify everything, so that we can efficiently, produce some more great advanced technology. For example, the study of black hole is so much critical for space exploration, is not because one day Earth will get dragged into the black hole. That is a very poor misconception. The study is important because if you know what is black hole, the star which is even larger than our sun, okay, that star when continuously collapse upon itself, and collapses into a single point, that is the center of gravity of that particular star. When it collapses into that particular point, the space time continuum gets intertwined, it gets entangled into itself, and that is how the black hole is created. Now just imagine something bigger than our sun. Our sun is 95 or 99% of total mass of our solar system. Now imagine that scale. And the star I am talking about has to be bigger than sun. That bigger star collapses into a single point. So that unifies gravitational force and quantum physics, which is not unified in any possible situation on Earth or in other places at universe. So the black hole is the only possible situation where gravitational effect and quantum physical effect unifies and merges into one single effect. And that is possible to observe and notice if we are able to see a naked singularity, because every singularity, that single point inside the black hole, is covered by event horizon, and event horizon never lets anything to escape. That you must have heard, that even light cannot escape. So if light cannot escape, how will you see what is being happening into that particular area. So that is why it is required to study a very particular unified equation. And for that particular unification of equation, you need to study what happened into time, back in time. So that is why we want to see the farthest, so that we can go back in time and we can see what happened. So we have observed many things and concluded till cosmic microwave background radiation. That was, I think, maybe, I don't know, if I can't put it in terms because I don't remember the exact value, but it was quite soon after the Big Bang blast. So that is how we are going back in time, looking at what happened at that time. So we also know about the situations of the Big Bang, but we cannot, we for right now we can just know that before the blast there was a singular point of infinite density and infinite temperature. That is the singularity. That particular singularity is what we are finding into some black hole. So we can't predict anything before Big Bang right now because we don't have any particular equation for, or even technology for that. But this thing is not to be told for sure, because maybe tomorrow we have something, maybe even 50 years later we don't have something that could predict before that time. Okay, so that is quite impossible to answer.
So, sir, there are only two questions till now, after which we can wrap up our Q&A session. So where should we approach for contribution in this field?
Where should we approach for
Contribution in this,
contribution?
like in the astronomical field.
See, that particularly depends on what you relate to most. For example, I have pursued mechanical engineering, then aerospace, propulsion technology, because from studying mechanical only I was very interested in thermal and fluid, which goes on to extend up to the inner, how should I say this, the inner workings and processes of engines, of cryogenic engines and jet engines, you know, engines that are used in aircraft to any space flights, everything, launch vehicles. So that is how I relate myself to space industry. Also, I like astrophysics a lot, because when you are not into engineering domain, when you are in high school or maybe even some lower grades, then you cannot understand physical phenomena, you cannot understand acceleration when you are in 8th or 7th standard. While I was fascinated to space science from that time, so that is why I read some books on astrophysics more than aerospace till 12th, maybe, yeah, till 12th standard. So yes, that way I know that how, what I like in particular in the complete space sector. So that you need to read some books, you need to go through some research papers, see what particular researches are going on right now, while what researches have contributed in what manner to the advancement of technology. So when you know those things in mind, you know what are your strengths and weaknesses. Supposingly you are not good with mathematics, then you must go for astronomy, because astronomy consists of some mathematics, but it is mostly on instrumentation. So when you observe something, then you have some radio frequency and some other infrared spectrum studies and observations, right? So that is why you need to first know what possible options you have to contribute in a space sector with respect to what you are studying right now. Because if you are studying BTech, then you cannot possibly think of pursuing something which requires a BSc degree, right? You are getting my point, right? So you need to focus on what options you have with respect to what department you are into, what field you are into, and then to see which option is best suitable for you with respect to your strengths. Then only you choose that particular option. Yes. So to make any type of contribution in any sector is your particular choice. I can't make that decision for you.
So one question is that what course or studies could we go through for securing a field job in this in astronomy, like to be an astronaut?
Okay, for see, to be an astronaut, there is not a particular degree or any course that you need to go through. First of all, I'll say to be an astronaut, you must be not present in India, because there are no manned missions right now. for America, they have very particular and strict rules. You cannot do even an internship in NASA if you are not an American. So you need American citizenship for that particular thing, and that thing is required for the astronauts as well. Now, if you are there with the citizenship and if you are working in NASA, then they have a particular page on their website where you can apply, and there are thousands of criteria that you need to satisfy as an astronaut. There is a criteria also for, there are certain sections for being an astronaut. Like there is a particular, I don't know right now, but I think 5 years back there was a particular section for just pilots. So even if you are not good in technical terms, if you are not even near any technical concepts, or you have not done BTech MTech, but you are a fighter pilot, if you are in Air Force, or you have been trained into Air Force, then you will be selected to fly that particular space mission. But right now they give that training to the scientists only, so that they have one less member who is not aware of technical concepts. So that is why you need to be sound in your technical concepts while looking out for the criteria that NASA or any company, that any organization that provides manned mission, you need to see what particular criteria they have set, because they have their individual criteria. Maybe some have some height criteria, some medical criteria, whatever that might be. You must see how you can satisfy those, and then to get enrolled in the program. But first of all, you need to get the citizenship of that particular country, or you need to wait for India to, fly its first manned mission, and for that you need to be into ISRO. Yes.
So there are a few more questions. If you have no problem, maybe could you answer those also?
Yeah, sure, sure. Why not?
Is it possible to create a black hole for a small period of time in a laboratory?
No, you can
Mm,
even try. You can try for that thing, but it would be very far away from what we have in the present day universe. Because see, black hole, not even you can try. Sorry, you can't even make it. I'll tell you what black hole is. So there is a star which is, there is a limit to it. So a star which is bigger than 1.4 times our sun, that is the Chandrasekhar limit. That is the name of that particular limit. So the star which is 1.4 times our sun will go into gravitational collapse when its internal nuclear fuel is exhausted. Our any planet, any solar system, any body is having some internal nuclear fuel. Like sun has the nuclear fuel which provides the thermonuclear fusion. We have our nuclear fuel which causes the convection of volcanoes. So when that nuclear fuel, due to thermonuclear fusion, gets exhausted and gets converted into iron completely, then there is no inward pressure. There are two pressures on a celestial body which is larger than our sun, 1.4 times than our sun. There is the gravitational force which wants to collapse the complete star into a single point, while that is called the outward pressure. While there is nuclear fuel inside the star which is providing the inward pressure. So that is why, that is how the star is existing, because the inward pressure is larger than the outward pressure. So when the inward pressure exhausts, the outward pressure takes control and it collapses upon itself. So when the star collapses upon itself, I don't, I can't even imagine that thing. So it would be hard for you to. So you imagine that scale, 1.4 times our sun collapses upon itself and collapses into a single point. And with that gravitational force and with that humongous force, the space-time fabric, the space-time continuum gets entangled into itself. Now you are talking about a laboratory, and we are talking about 1.4 times solar masses. So that difference cannot be, contemplated or in any way. So that is why it is not possible for us to create the same situation here.
I think this question also answers the next question. Like, if we are able to make artificial sun, then why not a black hole?
Yeah, that, it satisfies it.
Right. So, could you also tell the running program of the Indian Space Society, like how it exactly works and what exactly
See,
do you do?
yeah, I'll tell you something about Indian Space Society. So we are an educational company. We are not a product based startup that makes some launch vehicles or anything. We are purely educational based startup, and it is very related to the topics of aerospace engineering and astrophysics. While for astronomy, we have particular sets of events. So, for example, yesterday and day before, I think 2 days before yesterday, we had astronomy quiz and aerospace quiz. There are some of the events that are happening right now. I think 1 hour back, the art event has been announced on the social handles of the Indian Space Society. So if you are interested into pouring your space for pouring your love for space into art, then you must register yourself for it. It is all free of cost. So that is about astronomy. While for astrophysics and aerospace, we have live webinars. This is, I think, the fourth webinar or fifth webinar. While we are also announcing various online courses in next couple of days. It has not been announced, but because it is the audience is there right now, I should exclusively tell you guys. So the upcoming online course, first one is a 2 day online course on dark matter and dark energy, and the other online course is a 4 day online course on black holes. So the definition of an online course, according to Indian Space Society, as how we plan it, is that for each day we have 1.5 hours of session, just the way we had today. So for 1 hour we have teachings, while for half an hour we have holistic discussion and interactions. That may be extended if the participants are more enthusiastic about knowing some things or solving their queries. So that is about online course. So two online courses would be announced in some days. Online course on dark matter, dark energy, and on black hole. While live webinars on several topics are being held even now and then. So in that also you can enroll yourself into. While some other courses like I think one other course after the black hole course would be announced is on human space flight and astronautics. That is a complete package if you want to get enrolled into and learn more about space flights and other online courses and internships. And there would be an announcement of a virtual learning internship on satellite technology that would be announced, I think, after a month or so. So these kinds of teaching, it is an educational platform. So it is just about spreading the word and creating awareness, spreading that particular education that you guys need to understand what particular concepts are, and also to have that particular career guidance which the colleges and the faculties professors are not being efficiently doing right now. It was the same case for me also, and that is why I came up with this company, because I too suffered from the same problem. That when you go up, first of all, they don't do it voluntarily. No professor, I think there would be some exceptions, but most of them are not interested in your career. And those who are not able to properly guide you in terms of holding your hand and taking you to a career path, that see, these are the things, these are the objectives, you need to do this. So that is, I feel, is not quite effectively being done, and that is why companies like Indian Space Society exists. Yeah. So we'll take some last few 2 or 3 questions.
Okay, sir. So SpaceX is in the news currently for the last 2 or 3 months more. So what sort of exactly, like what sort of revolutionary ideas is SpaceX trying out, and how is it separate from NASA?
See, if you have gone through some interviews of Elon Musk, or some uh, websites that also write some blogs about him, so you must be knowing that he never sees himself as making some contributions to space technology or advancing the technology. He sees himself as a savior, not in terms of ego or any particular attitude, but he feels that human species are not supposed to be a singular planet species. So he feels that we should be intergalactic at some level, but at least interplanetic right now. So his particular aim is to find out how we can establish a living environment on Mars. So apart from pushing the technology ahead for Earth, he is trying to, establish that particular situation in Mars. So for doing it, he is pushing the particular technology. But the aim for having that advancement is not to, ease up human life on Earth or to make some notable contribution in space technology or space exploration. That is not his aim. His particular thing is to have human species spreaded all around the solar system at least. So maybe we have some space colony, maybe we are living on Mars. Space tourism is the perfect word to say what he wants to achieve in life. So that is what SpaceX is all about. And while NASA is it is a more diverse field than SpaceX, because NASA has been into the sector since it has initiated the sector. That thing should be correct to say, right? So NASA it is all about everything in space science. If you are talking about finding out some black hole, if you are talking about establishing colonies, or space tourism, or advancing the technology just to make the human life more easier on Earth, and to finding out some new materials, some new technologies, some new electronics, everything. So NASA is a very diverse field in that section. It has particular aims for particular sections, while SpaceX has just one aim.
Right, sir. So, is it okay if we take one last question?
Yeah.
So, are we able to figure out till date where did the Big Bang happen in the known universe, or where was the point of infinite density and gravity in the universe from which everything evolved after the Big Bang?
See, you can't possibly know that, because how should I say? There is a particular section in the space-time continuum very far from us, where you must be knowing that we always say observable universe, because the end of that observable universe, I don't remember the particulars of it, but the expansion rate is so exponential that the acceleration and the velocity achieved for the expansion by the space-time fabric itself is near, not near, but is equal to speed of light, right? So for that particular reason, you can't see beyond that particular limit. So that is why we always name it as observable universe. So when you don't know what is the complete thing, you can't find out what is the center of that thing. If you don't know a particular sphere, how can you say which one is the center? So since we do not know the complete scenario, we do not know what the complete universe is, we can't really pinpoint with exact details that this is the place where the blast occurred.
So, I think so that wraps up the Q&A session. If anyone having any last minute questions, they can ask right now. I think everyone is clear now, sir. So, what
Apart
a
from
marvelous
this, if
webinar, sir. Thank you,
yeah,
Mr. Patel, for your enlightening words. I'm
and
sure all the participants will be leaving this webinar wiser in the way of space.
I shall also write the mail ID of Indian Space Society in the chat box. So if anyone wants to contact in any way, they can.
Right, sir. The depths and the details in this webinar which I've covered is just truly amazing. I would also like to thank all the students, teachers, and others who attended this webinar. Your doubts and questions were indeed stimulating, and I'm sure everyone benefited from the answers given. Lastly, I would thank the Nakshatra Astronomy Club for giving such an opportunity to everyone, and thank the core committee for their efforts. So if you have any last words, you're more than welcome to say so.
Yeah, so lastly, I should really thank the college authorities as well as the Nakshatra Club, because this is something which needs to be, spreaded more, and the awareness has to be, carried on with everyone's efforts, so that we can reach that particular peak where everyone is aware on how to contribute and how to pursue that particular careers into it. So that's it. Thank you all. I shall thank all the participants also for joining and staying with us till the end. And I hope that it would benefit you somehow. And also the answers were quite satisfiable.
For all the participants, there is a feedback link active in the chat box now. Please fill that up before leaving the webinar. Thank you and good night.